Hello, my name is Matt Farrell, and our team consists of myself, Brian, and Vish. We'll be presenting on our topic of enhanced form search with a focus on Android-related data. We'll provide our email addresses again at the end of the presentation if you have any questions, since we're all online students. So let's get started. First, just to give you an outline of what we plan to go over, you can see here I will introduce our motivation behind the work that we have developed and introduce you to some related work which fits in the same realm as our form search implementation. Next, as we get into the methodology of our research, Brian will cover the custom quality classification metric that we use to identify our higher quality posts, and I'll give us a little information on how we set up the actual search tool for use on our test data. That will segue us to Vish, where he will explain how we collected our data and which data we selected for the search corpus, and follow up with results of the evaluation conducted. Finally, Brian will give us some final thoughts on future work and some conclusions that we drew from our own project. So as for our motivation, when a user is looking to search for answers to questions, especially on topics they believe other users have experienced and perhaps solved, form-specific searching almost inevitably comes up. Built-in search on these forms can often be bare bones. Perhaps they're part of an open source package that was not given much thought, provides some inaccurate results, or at worst only provides thread results which a user must then sift through to find the answers they're looking for. We attempt to begin to solve that issue with not only a more powerful search method, but one that also indexes data from multiple forms to avoid the extra steps of manually searching across all the forms on your topic. Our project offers an integrated quality classifier which can be used to enhance search results, which Brian will go into a little deeper later. Some clustering to offer assistance for finding better query terms and other related topics users may not have thought of, or better ways to recommend them to expand their search. And some thread level granularity in both providing a post level results, which users will expect, and an expanded search, which allows you to key off of a single post result and gather the entire thread of that post as a relevant sorted list of only posts inside of that thread, which can help you find information that you may be searching for on a more general topic. Related work in this area includes some classifications such as taking posts into question and answer classes, where it is attempting to draw connections between posts and identifying which are most relevant among those answers. Then it can attempt to match up your query alongside the question posts that are the predecessors to those answers. Sentiment analysis is in a few papers that we found and fits alongside our work nicely, since it could actually be integrated into our research into some future work to potentially offer very positive posts for users along with the high quality metric that we offer. So these two are somewhat complementary, more than covering the same ground, we felt. Topic modeling has also been used in this area to help identify topics that users may be attempting to locate answers on, and touches on our work slightly, though our clustering is a little more shallow than the other work that focused directly on it, but it does have some relevance here. These items are all just missing the piece of direct relevance judgments on the helpfulness of a single posting in relationship to the topic that it attempts to address. And this is where our project, hopefully comes in with assistance for users who may be browsing by showing them some thread relevant sorted items that I mentioned before and clustering topics from their results. And not to mention that obviously we were looking to aggregate a number of forms on top of all these additional features which were generally based on a single search of a single form.
If you're familiar with online discussion forums that serve an enthusiast or hobby group, you've probably noticed that they can contain some of the best and most up-to-date information on the web for their topic, but it can be difficult to uncover this information since it represents a small fraction of the overall post volume, and typically these types of forums are not very well organized by quality. So what we propose to improve this situation is a classifier that tries to predict whether an average user reading through a thread would find a given post useful or not. To do this, we define this usefulness or quality metric on a discrete scale of 1 through 5, where 1 is basically spam, all the way up to 5, which represents a very high quality post like an FAQ or a guide. Now, instead of trying to make this quality judgment based only on the raw text of the post, we can leverage the structure and metadata inherent in the forum, like whether a post is formatted using HTML. And once we get this post quality metric, we could use it in a lot of areas, for example, helping with search ranking. So perhaps you're looking for the answer to a question, and a post that asks the same question that you have would receive a very high relevance score. But we'd probably prefer to return a post that has a quote of your question and also provides a good answer to it, and therefore it would be considered a higher quality post. So we could also use this quality metric to help in our browsing scenario. So for example, maybe you're dealing with this massive thread like the one pictured here that has more than 34,000 posts, and maybe you just want to read through the higher quality posts in the thread to get a general idea. To actually implement this idea, we leveraged an existing toolkit called libsvm, which is a machine learning library that supports classification using a support vector machines model. So to do this, we had to quantify posts into a set of features which are basically numeric descriptions of the post. So we use things like its term count, whether it's formatted using HTML, as well as the thanks count, which is a form of user feedback found in many online forums, including the ones we studied. In total, we defined 12 features to use in our model. Now, since there's no explicit quality ratings available in our underlying data set, we had to provide manual ratings to train the classifier. We initially intended on using a random sampling of posts, but of course most of these posts are average quality, which meant that our classifier was not exposed to enough high and low quality posts to build an effective model. So we ended up getting around this chicken and egg problem with some extra manual labor and by using the existing user feedback as best as we could. One thing to note is that we found that the normalization of our data made a huge difference in the accuracy. So we saw an increase in tenfold cross-validation accuracy of close to 10% by moving from unnormalized data to logarithmic normalization. And overall, our classifier seemed to work pretty well, achieving about a 73.5% tenfold cross-validation accuracy compared to baseline majority class of 47%. Of course, more on that in the later evaluation section.
For the search tool, we utilized the search package Solar for many reasons. The primary one being the quick setup time and high customization that it made available, all based off of a Lucene search engine with just some additional features on top of it. It allowed us to define schemas fairly easily while controlling how those schema fields were treated as the built-in indexer ran. So Solar provided us with some clustering techniques, which we added to enhance the experience for users who are browsing the data and perhaps looking for related topics in their results. And as mentioned before, the sorted single thread results directly linking from the typical search result set of just post listings provides quick access to those threads that users have identified as useful and still allows us to help them rank posts inside of that thread so they can read the high quality posts in a quicker order and leave the less relevant ones or perhaps the meaningless ones for last. So Solar really allowed us to extract the specific fields that we wanted and keep them into data types that would give us the best results for boosting and other things like that.
Thanks, Matt and Brian. This is Vish. I'll be talking about source data forms we have used and motivations for using the source data forms, as well as the evaluation part of our tool. We initially started with 5 Android forms to scrape the data from, but we had to settle for two prominent ones towards the end. So basically, we wanted to demonstrate and apply course learnings in the project than concentrating on the data volume aspect of scraping the data. So we were looking for forms that is prominent in nature, which has substantial quantity and quality of threads and posts, as well as support with a large user base and activity volume, as well as a quick response time for threads and posts. We also considered ease of scraping the data we were looking for. Based on that, the two prominent forums were Android forums and XDA developer forums. So, brief statistics: XDA developers were having about 5 million members and 50,000 online members in peak, about 2 million threads and 51 million posts. AndroidForums.com was having about 1.3 million users, 715,000 threads, and 6 million posts for these threads. So we were looking for some scalable scraping tool which could extract the data we were looking for. So our ultimate choice was Scrapy. So we wanted to represent the posts and threads data in a normalized way so that indexing can work on some common data representation. Also, we could scale the project for different source form, which is just matter of defining the experts for each source forum. So Scrapy, we defined two items, one for thread and one for post. So one expert per field per source forum is how the Scrapy definition goes. So the thread content was like title, link, thread ID, forum ID, and view count. And the post data had author, post ID, thread ID, content, and thanks count with the date. So XDA developer phone took about 14 hours to scrape the data, and Android phones took about 10 hours to scrape. Basically, we concentrated on Android phone for Nexus phone with a general topic. Now the most interesting part, evaluation. How well did the tool perform? We did two evaluations to understand how well the tool performed. One was the search evaluation and the second one was the classifier evaluation. For search evaluation, we computed map at k equals 10, where it is precision at 10. So out of the 25 results returned, we computed precision for top 10 queries. So we ran this map for about 7 queries handpicked. The queries were such that each one of them had some kind of judgmental answers and not any opinion-based queries which has answers which are subjective. So this is just to make our ranking, relative ranking easier. For future consideration, we wanted to automate the evaluation. That's when we could quickly run the tool and tune it to get optimal performance. So we arrived at a map value of 0.46 against targeted map of 0.6. There is still scope for improvement, which is in our future consideration. So for the classifier evaluation, we computed students' paired t-test on two different data sets. One is the training data set, which had around 147 posts. So we manually graded each of the posts and compared it against classifier graded posts. So we arrived at p-value of 0.1069 against alpha of 0.05. So at 95% confident, we were not able to eliminate null hypothesis. So this means that the two systems, like the manually graded system versus classifier graded posts, they are very close to each other. The second sample data set were hand-picked 60 posts. So we again repeated the test where we manually graded the 60 posts and compared it with the grading outcome of the classifier tool. Then we computed p of 0.0921 against alpha of 0.05. So even here we had some positive result where the classifier output grading was very close to the manual grading.
So we identified a few areas of potential future improvement to our work. For the classifier specifically, we felt that we could extract more features from the post, especially those that would provide some more insight into the author. So for example, average post quality of the author's previous posts. Our classifier could also benefit from a larger data set for training and evaluation purposes. And we also figured that we could make use of sentiment analysis techniques to gauge the unstructured verbal feedback to a given post and incorporate that into the quality metric. So for example, if a post gets a lot of really positive feedback and follow-up replies, we could use that to boost the quality rating. And on the searching front, we could expand our evaluation to give us some better insight into its true level of performance and allowing for better tuning of the scoring method. And it would be ideal if we could do this in some kind of automated fashion. Well, that's about it for our presentation. If you have any questions, please feel free to send us an email. Thanks for watching.